So in these reaction right here, we're going to balance redox in acidic solution. This is a little bit different than my first video because we're going to have to balance oxygens. So a couple of things. So you balance everything besides oxygens first. You're going to balance oxygens by adding water, and then balance hydrogens by adding H plus, because acid means H plus, and then add electrons to the more positive side. So we're going to come back to this, but again, the difference is I'm going to add oxygens to balance, or add waters to balance oxygens, and then we're going to add H plus to balance the hydrogens. So let's break these down into half reactions again. So we'll break down from this. Again, this is a dichromate ion and the chromium ion, and then this is actually nitrous acid and the nitrate ion. So let me break it down to half reactions, then we'll go from there. So just like we did before, now I have two chromiums here and one chromium there, so I got to balance everything besides the hydrogen or oxygen. So I'm going to put a 2 there. Now we have oxygens. I have 7 oxygens here, no oxygens there, so I'm going to add 7 waters. Because 7 times that 1 oxygen means 7. A couple of things. Now I'm going to balance the hydrogens. So 7 times 2, I have 14 hydrogens here. I got no hydrogens here, so I'm going to balance it by adding 14 H plus. So again, balance the oxygens by adding water, balance the hydrogens by adding H plus. That's countable to charges. So I got 14 positives plus 2 negatives. On this side, I have positive 12. On this side, I have positive 6, because I got 2, each one is positive 3. So again, go back and review that if you're having problems with it. So I got to add 6 electrons here. So I'm going to try to squeeze it in. So 6 electrons plus 6 negatives is equal to positive 6 to balance out the charges. I'm going to do the same for the bottom one. So in this case right here, my nitrogens are the same, so I don't have to worry about that. I got 2 oxygens here, 3 oxygens there, so I got to add 1 water. 1 H2O. I got now 3 hydrogens here, none there, so I got to add 3 H plus. On this side, this is neutral. On this side, this is positive 2. So always add electrons to the more positive side. So I'm going to add 2 electrons. Once I've done that now, I got to even out my electrons. So this side is actually reduced. So if you add electrons to reactants, it's reduced. This side is actually oxidized. My electrons have to be the same. So least common multiple, I have 2 here, 6 here. I'm going to multiply everything here by 3. So what I've done is, so that first reaction we left alone, so we didn't have to multiply it by any number, but the second one we had to multiply everything by 3, so I went ahead and did that. So 3, 3, 3, 3, and 3. So this is my second reaction. Now we're going to cancel what's the same on both sides. So I have 6 electrons here, 6 electrons there. They're the same. Now let's look at the H plus. I got 9 H pluses here, 14 H pluses there. So this 9 cancel out. So I'm going to be left with 5. So again, you cancel what's the same on both sides. 3 waters here, 7 waters there. So I'm going to be left with 4 waters. And then we just write down what's left over. And so when you do that, we actually end up with this. So it's acidic, so we know we're going to have H plus. I've got 5 H pluses, 1 dichromate, 3 nitrous acids, 3 nitrates, 2 chromium ions, and then 4 waters.